So here we are today to talk about the difference quotient. So for the two objectives that are on the screen right now, we are going to be working on the calculating the difference quotient of a function, and that we want to understand that the difference quotient gives the average rate of change for a function throughout the function in a very general case. If we had a previous lesson on the average rate of change between two specific points, one way to think about that is this is a specific average rate of change, whereas the difference quotient is more of the general case for the average rate of change. And because it's been generalized, there's not going to be any numbers. We're going to be working with functions, inputting expressions into them, and performing a lot of algebra, and our answer might not be numeric. In some cases it is, but most cases not. So if I go back to our illustration of our average rate of change, and we want to generalize it for any 2 points, what we're going to do is we are going to change our formula slightly. Before, we had our average rate of change formula being f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. What we're going to do is we're going to generalize this a little more. Instead of having specific values for x, what we are going to do is have our point P, and we're going to give it coordinates x comma y, and we're going to leave that as is. Where the big change is how we are going to treat the difference for q, and mostly within the x coordinates. It's going to be what's important there is the x coordinates. What I can do is I'm going to look at, and let me choose a color here, the distance between the x coordinate of point P and the distance to where the x coordinate of Q is. And I'm going to call that distance between those points h. All right. Now, furthermore, from the origin to the x coordinate of P is a distance of x. That's what an x coordinate is. It's a horizontal distance. So from the y-axis, from the origin, I've moved x units to get to point P. And then to get from P to Q, I'm going to move another h units to the side there, which means that at this end right here, this Q, the x coordinate of Q can be described as x plus h. So that's what we're going to do there. Instead of calling the x coordinate of point Q x sub 2, some specific x sub 2, we're going to say, well, we went h units past P's x coordinate. And so what that's going to do is it's going to change our average rate of change formula, this specific formula here, and we're going to make just a couple of substitutions. So instead of having f of x sub 2, we're going to have f of x plus h, because the x coordinate of q we're calling x plus h now, minus f of x, we're getting rid of the sub notation because we called the x coordinate of p, we just called it x, over x sub 2. Now x sub 2, my second y coordinate, is the y coordinate of point, sorry, is the x coordinate of point Q, and we're calling the x coordinate of Q x plus h, minus x sub 1. X sub 1 was the x coordinate of P, and we're just going to call that x. So a slight change, and then one more change, because if I look here at the denominator of my current formula, I have a positive x minus an x. Those would give us 0. And so now my final difference quotient is going to be f of x plus h minus f of x over h. So this is now what we call and refer to as the difference quotient. This formula right here is what is known as the difference. Let me use a different pen here. What is known as the difference quotient. Now, to calculate the difference quotient really relies on being able to use function evaluation and then algebra skills of distribution, combining like terms, and simplification, so on and so forth. If you struggle with those, you might want to go find a video, ask your teacher, find somebody to talk to about that as well. So this is where we're going to go from here, is using this difference quotient. One more note before we move on is I would like to point out that the f and the x and the h are not important. We might have a function that's p of q or something like that, but it's the general idea of what we're going to have here. So we're going to do a couple of examples just to demonstrate how to calculate the difference quotient. So we're going to calculate the difference quotient for f of x equals 2x squared plus 1. You'll note here, as opposed to the average rate of change, I haven't given you any specific x values because we don't need any specific x values. We're doing it for the whole general case. I'm going to start by writing the formula for the difference quotient. I'm a big believer that we should write formulas as we're learning them, write them and write them and write them. It helps to move from the short-term memory into the long-term memory. And now I'm going to calculate this. Now, I'm going to draw my fraction bar, and I'm just going to put the h in the denominator. Now it's a matter of getting my substitutions correct. So the first thing I have to do is figure out what f of x plus h is. So I'm going to put a bracket here to separate it out. And the rule, my function says f of x equals 2x squared plus 1. That's what my function says. Now, though, I have x plus h in the parentheses. So everywhere I saw an x previously, I'm going to replace all of these x's with x plus h. So that is going to give me 2 times x plus h squared plus 1. Close that off. So now that is my new version. This is what f of x plus h looks like. Then I have to do minus f of x, and that's easy. That's just the rule. That's just 2x squared plus 1. I'm using square brackets here as a grouping symbol. You could use parentheses. But a grouping symbol is important on the minus f of x. Otherwise, you would not distribute the negative through the terms, and you would have a sign error, and you would not get the correct answer. So there's our function evaluation, our matter of getting the right things into the right place. Now it's simply a matter of being able to perform the correct calculations. So I'm going to have an equal sign here. I'm going to make a big fraction bar, give myself some space. My denominator of h is just hanging out for a few minutes. So I recall that x plus h squared really means x plus h times x plus h. I have my plus 1. And then I'm going to distribute the negative through there, through the second set of brackets, minus 2x squared minus 1. Just following order of operations, I'm going to start by multiplying x plus h times x plus h. And the 2 is just going to hang out. X times x is x squared, plus xh plus hx plus h squared plus, close that, plus 1. There's my other bracket. Minus 2x squared minus 1. That stuff just hangs out for a minute, as does my h. Maybe I'll give a little more space between my pieces there. Let me just slide that down, a little more of a visual gap. So that's where we're sitting there. Little more simplification. I'm going to distribute the 2 through the large set of parentheses, and I'm going to combine like terms. I've got some like terms here, so I'm going to combine those at the same time. That is going to give me 2x squared plus 4xh. 4xh because I have 2 xh's in the parentheses and then the 2 from the outside the parentheses. Plus 2h squared plus 1 minus 2x squared minus 1 all over h. So now I have no more multiplications to perform, so now I can start looking at combining like terms. I notice that I have a positive 2x squared and a negative 2x squared, which are going to combine for a 0. I notice that I have a plus 1 and a minus 1, which are going to combine for a 0 and disappear. And so my next line, just to make it easier to look at, is going to 4xh plus 2h squared over h. Now at this point I want to point out that there's a good cue that I'm on the right track. If when you get to this step, after the canceling of like terms, you get to this, and we should have every term in the numerator has a factor of h. When you have that, when each term in the numerator has a factor of h, you're on the right track. If you have terms in the numerator that don't have h's in them, you made a mistake somewhere. You need to go back, check your substitution, check your distribution, check your like terms, check your arithmetic. You just made a mistake somewhere. I see that my first term, 4xh, has an h, and my other term, 2h squared, has an h. What that allows me to do is factor an h out of the terms. So it'd be h times 4x plus 2h all over h. And I can cancel those h's, leaving me with 4x plus 2h. And that is the answer. That is the difference quotient for the function f that we started with. Now what this means, this is essentially remembering that we're getting here a slope of the secant line. But instead of it being the slope of the secant line for any two specific points, it's the formula for the slope of the secant line across the entire function. It's something we can use going across the entire function. So it's still a slope. But the answer isn't a number. It's a formula. And that's okay because we've done the general case as opposed to the specific case. Now, you might be looking at this and saying, hey, that's a pretty intimidating problem with a lot of steps. And that's absolutely true. Just take it one simple step at a time. Get your substitutions in the right place. Pay attention to your order of operations. Do some distributions, combining like terms. One thing at a time. I also recommend being really good, neat, and organized with your work. Try not to cut any steps because there are a lot of places where you can make mistakes. Let's go ahead and do one more example and take a look at that. And let's calculate the difference quotient for x squared minus x. So we'll start with the same difference quotient formula, f of x plus h minus f of x over h. Over h. So for my f of x plus h, that's what I have in the parentheses. So in my rule, anywhere I see an x, I'm going to replace it with x plus h. So I'm going to make a set of brackets here. And the rule says x squared. So that's for me going to be x plus h squared. Minus x, well, that's going to be minus x plus h now. I'm replacing x's with x plus h's. Close that off. Minus the function, the original function f of x. This just says take the original function f of x. So I can take the original function and just write it out. X squared minus x. A little out of room there. Over h. So the first part is to get my substitutions correct. After this, it turns into just some algebra and arithmetic. Make sure we get it right. I'm going to come down here. I'm going to give myself plenty of space. I know that the h is just going to hang out for a few minutes. My first set of brackets turns into x plus h times x plus h. And I'm going to distribute the negative through the second set of parentheses, minus x minus h. Close off the brackets. Minus x squared plus x as I distribute the negative through the second set of brackets. Once again, the brackets are important to remind yourself to distribute the negative. Otherwise, you're going to have a sign error, and you're going to have a mistake. Continuing, nice big fraction bar. My h is going to be hanging out there. My bracket, when I multiply x plus h times x plus h, I'm going to get x squared. And on this distribution, I'm going to have an xh and a second xh. So I'm going to streamline it and just write plus 2xh. And then my last distribution of a plus h squared minus h minus x minus h that are hanging out from the previous distribution minus x squared plus x. Just bringing that stuff down. I performed all my multiplications. Now it is time to start looking at any combining of like terms. I notice a positive x squared and a negative x squared for a 0. I notice a minus x, with a plus x, and that is gone. And I have no more like terms. I have a 2xh, a plus h squared, and a minus h. I can't combine any of those. But like I said in the last example, all of my terms in the numerator have a factor of h in them. So I've got a good clue that I'm on the right track. I will factor 1h out of each term. One thing to be careful for is in the third term, when we factor an h out of negative h, we're left with a negative 1. Some people make the mistake and say, well, the whole term disappears, but it factors out a negative 1. If you struggle with factoring, remember you can check factoring by distributing, by redistributing what you factored out, and you should get the line that you had above. So that's something you can check out there. Regardless, my h's cancel out with each other, and I am left with 2xh plus h minus 1. And once again, we're talking that's the difference quotient. It's a formula for the general case of the slope of the secant line. Honestly, in this video, we're just practicing getting the answer. What it means is more of a calculus question. You might have to search another video or talk to your teacher about what that means. Right now, we're just practicing getting the answer. Once again, pretty intense in terms of algebra. A lot of steps, a lot of places to make mistakes. I really highly recommend organization so we can do this without making any mistakes. And just take it one little piece at a time. I hope you found this helpful, and we'll do a few more problems if you're one of my students when we get into class to practice this. Thank you.